Welcome back to Explaining Everything, the channel where we dive into the stories and mysteries behind everyday things. Today's question comes from one of our curious viewers, TechnoTurtle27. Thanks for the suggestion. You asked, how do satellites communicate with Earth? Fantastic question, Turtle. Because let's be real, satellites are floating thousands of kilometers above us, zooming around Earth faster than your crush replies, "Seen." And yet, somehow, they manage to send GPS signals, weather data, and high-definition pictures of hurricanes without yelling, "Hello, can you hear me?" into the void. So today, we're breaking down exactly how satellites talk to Earth, how we talk back, and why the whole thing hasn't fallen apart like my New Year's resolutions. Let's launch into it, right here on Explaining Everything. Okay, first things first. Satellites communicate using radio waves, not sound waves, not smoke signals, and definitely not space Bluetooth, although that sounds awesome. Radio waves are a type of electromagnetic wave, the same family as light, microwaves, X-rays, and whatever comes out of your weird LED desk lamp. These waves travel at the speed of light, meaning they can travel from a satellite to Earth in under a second. Here's how it works. Satellites have transmitters and antennas. They send radio waves filled with data, numbers, images, GPS coordinates, weather information, and probably your location when you're trying to hide from responsibilities. On Earth, we have ground stations, which are basically giant metal bowls, antennas pointed at the sky like they're waiting for the universe to call them back. When the radio waves arrive, the ground station catches them, decodes the information, and boom, you get a weather report telling you it's 50% chance of rain, even though it's clearly sunny. The important part, radio waves can travel through space because they don't need air. Unlike sound, which dies instantly in space because space is basically the universe's giant noise-canceling headphone. Now, the next big question. How do we keep the signal steady if satellites are moving faster than your Wi-Fi drops during a Zoom meeting? Great question. Low Earth Orbit, or LEO satellites, like the ones used for imaging, travel around Earth at about 7 to 8 kilometers per second. That's right, per second. If humans moved that fast, we'd all look like anime characters teleporting through life. Because they're moving so quickly, ground stations have to track them. The big dish antennas literally rotate to follow a satellite across the sky. It's like trying to keep a laser pointer on a cat, except the cat is in space and weighs thousands of kilograms and costs several $100 million. On the other hand, geostationary or GEO satellites don't move relative to Earth. They orbit at the same speed Earth rotates. They stay in one spot above the equator at about 35,786 kilometers high. This makes communication way easier. The ground station just points at one spot and never moves. Your satellite TV. Yeah, that's thanks to a GEO satellite calmly sitting up there like, "I'm not going anywhere." There are thousands of satellites up there. If they all screamed radio signals at once without rules, we'd get chaotic space karaoke. So how do they avoid mixing signals like a blender full of static? They use 3 main tricks. Different frequencies. Just like radio stations on Earth, satellites use different frequency bands. Some examples. L-band, GPS, S-band, weather and scientific missions, Ku and Ka-band communications, high-speed data. Think of frequencies as lanes on a highway. If everybody stays in their lane, no crashes. Hopefully. Directional antennas. Satellites point narrow beams toward Earth instead of blasting signals everywhere. It's like whispering directly into someone's ear instead of shouting across the room. Timing. Some satellites take turns sending data, especially in crowded orbits. Basically, you go first, then me, then you again. It's the world's most expensive group project communication system. These methods prevent crosstalk, interference, and accidental "oops, we just downloaded weather maps" through a GPS satellite. Satellites don't just yell downward, they also listen. Ground stations send commands upward, things like rotate 10 degrees. Take a picture of that storm. Stop ignoring us and respond, please. To send signals upward, ground stations use uplinks, high-power radio transmissions aimed precisely at the satellite. The satellite receives the signal through its antenna, processes it, and obeys like a very expensive metal pet. NASA, ESA, and other space agencies use huge communication networks like the Deep Space Network, DSN. 3 massive ground stations around the world that keep contact with spacecraft anywhere in the solar system. Some satellites even talk to each other and relay messages down to Earth, like, "Hey bro, can you deliver this data for me? I'm on the wrong side of the planet right now." So, here's the whole story in one breath. Satellites communicate using radio waves traveling at the speed of light. Ground stations catch these waves with giant antennas. Satellites move incredibly fast, so stations track them like space paparazzi. They avoid talking over each other by using different frequencies, timing, and directional beams. And Earth sends commands back using uplinks. It's not magic, it's not Bluetooth, it's just physics, antennas, and extremely disciplined radio waves. If you like this video, hit that like button and subscribe. Also, if you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. If you enjoyed this video, please check out our other bingeable channels. Thank you for tuning in and join us next time here in the channel that answers all the why, what, who, where, and how questions you've always wondered about here on Explaining Everything.